So I'm going to print this force calibration part on the Octave Lite using the same configuration settings as the first time. So I'm going to hit the play button on this, and that should begin the print sequence. It's going to ask me, hey, make sure there's nothing in there, and I'm going to hit OK. It's going to do a zeroing, and then it's going to lower the build plate into the resin. It's actually going to lower the build plate all the way down to the bottom, which can take some time because it wants to go down slowly so that it doesn't create too many bubbles when it goes through. This machine is actually chock full of sensors. There is a laser sensor mounted on top of the arm here. And that laser, the arm is the recoater wiper. And the laser sensor detects the top surface of the resin. If the laser sensor settles over, you'll see it's going down now. What it's doing now is the sensor is trying to locate the surface of the resin. And if the sensor is unable to locate the surface of the resin, it might get it wrong and like plunge into the resin. You're supposed to, if the recoater blade ever touches, there we go. And that pull up is basically there's some suction when the Z tries to come up. It's going to come up, and the Z is going to lower down slowly to the level of the resin. And that means the machine has to be really level. There is a relatively intensive leveling process that you have to go through to make sure that the machine is level to the squareness of the recoater blade. You need that to be, if you're printing at 100 microns, you really want it to be somewhere in the 20 micron range. If you're printing 10 microns, you need to have that resin level with respect to gravity at like the 3 micron range. So we just had a cycle here. And what's happening here is the light, which you can see here is kind of blue, is illuminating the resin. And that is a custom beamer. That is a UV beamer. I'm going to position this here so we can see the next one more clearly. With fixed focus. There's no focus because the projector should always be a fixed distance from the surface of the resin, controlled based upon the laser sensor. So it illuminates, and then it lowers the build plate. The sweeper resets, the build plate comes up, the sweeper sweeps over the surface to smooth it out, and then we illuminate the next layer. So there's this orchestration between the Z-axis, and the Z-axis is the projector plus wiper assembly, and the W-axis, which is the build plate motor, and then the C-axis, which is the angular axis. That's the number of degrees where the sweeper is at. All of these are controlled by steppers, and in the control software, you can actually control specifically where where all of these are set. The actual stepping of the motors is kind of noisy. This seems to be because the stepping itself is controlled by the firmware on the printer, and they wrote their own software to step the motors. So there was actually a problem where the stepping was causing a resonance, and one of my axes wasn't moving. They sent me a new version of the software, fixed the problem completely. But everything about this machine, the different parts of the machine, the software parts, are all they're all custom to the machine. And so you'll see here, when we look at the software window, that we can see that there are commands being sent to the printer. and these are what they call M code, which is, I mean, it connects to the computer as if it were just like any other serial UART device, and it sends a series of commands to it, but you can see that the command sequences are a bit more complicated than G code. There's some JSON-like syntax in addition to the code and the code numbers. And the code actually contains a number of safeguards to, say, prevent the Z and the W axis from crashing into each other, and to prevent the printer from operating with the doors open. You'll see here that my doors are open here right now, and that's because I'm defeating the interlock here. And normally you are not supposed to run the printer with the doors open. And actually, if you open the doors, the firmware will actually force you to rehome the axes, since it doesn't know what you might have done with it. So this sequence will just continue on, top down. Until the part is fully built. But notice there's no separation forces, no kind of bottom-up tension, which means in theory, if I wanted to print something like an inverted pyramid, it should be possible. The build plate is perforated so that the lowering doesn't accidentally unseat the build plate. It reduces the amount of displacement when the build plate drops. That does mean that the bottom of your print is going to have the shape of the perforation in it as a downside. On the upside, you might be familiar with both FDM and other SLA printers where you need something like this handy scraper. This build tack scraper is specifically designed for removing parts from a build plate. I use it for both FDM and SLA prints on my bottom-up printer. On a top-down printer, or because it has holes actually, I don't need to scrape it. The Octave Lite comes with this this grid here, and this grid aligns to the perforations in this hole, which is in the build plate, which is very clever. So you just kind of line this up, which is easier to do with two hands. And then you push it down, and that will pop the part right out. I've used this on two parts so far, and it works great. It pops out the parts real easily. This is not a printer for, I mean, so this printer was pretty expensive, right? It was like $5,000 on Indiegogo. So no secret, this printer is not a cheap printer. For a top-down printer with the wiper blade, I think it's the only printer in its price category that you can get regardless, especially since it has the custom UV beamer here. Or it's 405 nanometer beamer. Plus, I mean, these parts are just gorgeous. I mean, this whole machine screams custom built. All of these parts are CNC milled parts. You can see also like this cylinder here is clearly a lathed part. These knobs here that are used for leveling, you can feel the nub in the middle from the parting on a lathe, and the knurling on the side of this is fabulous looking. You can see the curves on the custom milled part here, but not a cheap printer. It's also not cheap on resin, right? I mean, I have 2 liters of resin in here, and you'll see how far down I am on the tank, right? Getting down to the minimum. In order to use the full 20-something odd centimeter height, you're going to need to fill this to the top. In theory, you could do the whole salt water thing, whatever. I haven't actually tried. You have to make sure that the laser sensor was okay with it. I mean, which it should, because the resin floats on top of the salt water or whatever, but that's definitely, again, not to spec. Using this printer properly, you should be filling this tank completely, which is, I think, 5 liters. So you're not going to be, this is not going to be a thing where you like dispense just the amount that you need, print with it, and then switch resins. It comes with 2 tanks because putting 5 liters of resin back into 4 or 5 bottles after you're done is not entirely practical. You are probably going to leave the resin in here all the time, and it comes with a pretty nice cover for these tanks, which have a reasonably good seal. You'll see that there's a lip here that'll go in, settle into the resin tank, and it does a pretty good job of covering that tank. The tank is pretty well made. It's made to be sturdy. I think that some of the seams, the ceiling here is not as pretty as it could be, but all of this it feels like epoxy. It's not silicone, and it's sealed on both sides, on the outside and on the inside, to prevent leaks. You can see that there's probably a heat formed. This acrylic part here is probably heat formed in that there's only one corner here, and the other parts are bent. I do have a heat gun here because the heat gun is good for getting rid of surface bubbles, which I didn't have a problem now because I printed yesterday. I left the resin in the tank and just swirled it a little to mix it up. But if you were filling this tank from bottles, the pouring action would generate a whole bunch of bubbles. You're scared of bubbles because you're scared of fooling that laser sensor. So I use the heat gun to get rid of any surface bubbles before the start process. So we can see it is beaming, and then sweeping. In reality, I mean, since the tank is itself colored, even with it open, not much UV is getting in. This is mainly, I think, to protect you, because these are big NEMA 23 steppers, and this head here that contains the beamer, right? This is the calibrated part of it. So you don't want to have anything get in here and interfere with it. You don't want to bump into it while it's moving. If you throw this machine out of whack, I'm not sure how you would recalibrate it. And so the enclosure here makes sure that you, generally speaking, keep the machine closed 99% of the time, and therefore protect yourself from any accidents where you might actually knock this thing out of alignment. It comes pre-calibrated out of the factory, and it does not seem like you really want to service this part. There are end stops all over. You'll see that here is the Z-axis end stop, and then over here that's the W-axis end stop. And there's some other mechanism that's used to detect the 0 point of the recoder blade. I'm not quite sure where it is. You can see that these are really nice lead screws here. Actually, I think that these are, looking at the shape of this coupler, I think that these are ball screws. So these are really nice, really heavy components. I'm not sure if you need something so heavy for the build plate mechanism, but since the whole the beamer, the projector is also moving, you need something hefty to make sure that this projector is going to move as fast as and as reliably as it needs to. Prints on this have been super easy. The very first print I put out succeeded. I canceled it because I had the wrong settings and it was going to take too long because I sliced it at 50 instead of 100 microns. But the remnant that I took out after I canceled it was perfect. We'll see what this part looks like when it comes out, but I mean, getting parts out of this printer compared to bottom up, where you have to deal with the separation forces, is just super easy. The amount of force put on the part by the lowering is like real small. the printer itself ships fully assembled, which is both a kind of a blessing and a curse compared to, say, the way that my trusty Titan 1 here was packed. The Octave Lite ships in a 150-pound wooden crate. This thing here. If you had a couple of people unboxing it, you could probably get it out. To make it easier for me to unload myself, I took a whole bunch of the walls off, which you can see here, and then lifted it out. The printer itself is not 150 pounds. The crate itself is pretty heavy. I actually had a bit of trouble because this is an unusual item to ship. It's unusually big, and I had it shipped to my office, and the office mailroom was like, you have a crate. We can't do anything with it. You're going to need to have some professionals take care of this. It does come, the crate, with standoffs on the bottom. So if you have a pallet jack, you may be able to fit it under, but it doesn't have it's not a full 2 slots wide. It's only kind of 1.5 slots. What this does, though, is it makes it pretty clear exactly where the bottom is. And it also provides a good platform for you to grab onto, since it is so heavy. So when me and the guy hired to help me were lifting this, right, this was pretty easy because there's no crushing our hands on the bottom. But definitely this was a pretty hefty item to be shipped. On the other hand, the total amount of time it took to set it up was quite fast, because you open it up, you pull it out of its external packaging, you place it, and then there's a piece of foam on the inside, which you can see here is kind of the same profile as the doors. On the inside, you open the doors, you pull this guy out, and you plug in the printer, and you're ready to go. There's no screws, not a single screw. The only time-consuming setup step is the leveling, which I probably have to do again. It's a 4-point leveling system, which is always a bit tricky to deal with. I mean, not that it's any different than, say, the Taz 4 here, which is also a 4-point leveling bed, something I've never done before. But you need to be really exact on the level. You want from the left side to the right side for there to be, less than 5 microns deviation from left to right, which is time consuming, especially because you have to read it using the laser sensor. And so the laser sensor will kind of sweep, and I'll probably do another video on how that works. And after I figure out a better way or faster way to do it than I did it, and then get the knob set. The screws here are pretty nice. This is the screw at the top that turns the foot, and then there's a kind of this locking screw here that you turn the other direction that'll help you lock it in place once you've got the position right. This is 100 layers. So we'll come back here. I'm on 46 now, just from yapping away. We'll come back when it's complete. Okay, so now we're on layer 100 out of 100, maybe 99. This is either the last or the second to last layer. Okay, it looks like this is the last layer now. It's illuminating. See, there's a little bit of blue coming out of there. Alright. And then the Z-axis, rather, is going to lift first to give clearance for the W-axis to swing up. Alright, you can see that there's this, when it's up here now, there was this big swing way out here, so the door would prevent anything from getting in the way of that. And here we are. We've got the part. And you see it's still dripping and stuff, so you're going to want to let this drain off a bit before working on post-processing and deplating it.